Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So this is another lecture from the Strivers A to Z DSA course. Just in case you're for the first time here, this is world's most in-depth course when we talk about DS Algo. Why do I say that? This course has 455 modules. By the end of the course, you'll have solved more than 400 plus problems in DS Algo. You can go over the entire internet. You can buy any of the paid courses. None of them will be teaching you DS Algo in such depth. Something that I can give you as assurance is once you complete this entire course, you can clear any of the DS Algo rounds in any of the companies in any part of the world. So till now, we have covered up till this particular problem. Now in this video, I'll be covering up the problem majority element n by 3 times. But please, before watching this video, go back and watch the video majority element n by 2 times. In that video, I've explained the algorithm and intuition in depth. And for this particular problem, I'll just be using that algorithm and intuition to derive a solution for n by 3 times. So if you haven't seen that particular video, there's a link in the description. Pause this video, go back and watch it, and then only resume it, because if you haven't seen it, you won't understand anything that I'll teach in this particular video. So what does the problem actually say? Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So this is another video from the Strivers A to Z DSA course. Just in case you're for the first time here, this is world's most in-depth course in DS Algo. Why do I say that? This course has 456 modules. By the end of the course, you would have solved more than 400 plus problems in DS Algo, and you can go across the entire internet. You can buy any of the paid courses. None of them will be covering DS Algo in such depth. So one thing that I can assure you is, once you complete the entire course, you can actually clear any of the DS Algo rounds in any of the companies in any part of the world. So till now, we have covered till certain array of zeros, ones, and twos. And in this video, I'll be covering majority element. So what does the problem majority element states? It states that you'll be given an array of integers. Now your task is to find me the element that appears more than n by 2 times. Very important lining. More than n by 2, not equal to n by 2. It has to be more than n by 2. Imagine n is 8, then it should appear more than 4 times. Imagine n is 9. In that case, 9 by 2, you'll take the floor value. It is 4, so it should appear more than 4 times. Got it? So in this array, if I ask you, which is the majority element? How many, what's the length of the array? 3, 4, 5, 6, 7. 7 is the length of the array. Can I say 2 appears for 4 times, which is greater than n by 2? So 4 over here is your answer. And this is what you have to tell me. Given an array, tell me the element that appears more than n by 2 times. So what will be the brute force solution to this particular problem? It's going to be very simple. I'll pick up an element and then I'll scan through the entire array. Basically do a searching through the entire array. And I'll count plus plus. And if at the end of the day, the count appears to be greater than n by 2 for any of the element, that is my answer. First I'll pick up 2, next I'll pick up 2, next I'll pick up 3 and scan through the entire array, next I'll pick up 3 and scan through the entire array. This is what the brute force solution will be, and the code will look something like this. So it's very simple. You just iterate through the entire array. For the first time, pick up 2 and scan through the entire array. Then you return array will look like. What will be the time complexity? Obviously, we are using a couple of loops. So what will be the better solution? The brute is taking n square. So we know one thing for sure. The better solution will be somewhere of the order n log n or b go. And we're looking for which element appears more times it occurs. The only technique in the count where the greater than v dot. There was no one. You can simply say return -1. Everything is the mix of n. If you use another map ends up taking b go of n time, will be in the map. B go of n to traverse in. Can you please optimize this? That's when you'll be talking about the most algorithm. So you have to know this algorithm beforehand. So you might be thinking, but does that mean we have to mug it up? No. The interviewer will be grilling you on thought process and intuition. If you mug up the algorithm and you just present it line by line, you'll understand that you mugged up the algorithm. So please make sure you understand the thought process, intuition, and the algorithm in depth. So please make sure you watch the video till the end, because you're going to take away a lot of things when the video ends. So how will I be explaining this particular algorithm? What I'll do is, I'll do a dry run of the algorithm. And during the dry run, I'll be sharing the thought process and the intuition behind every step that this algorithm does, so that it sticks to your mind, okay? So what is the algorithm all about? It's very simple. It's about two variables, element and count. Initially count is 0, and you can say initially the element is not initialized. And we start iterating. So whenever we're iterating and we have the first element or whatever, if the count is 0, that means we haven't taken any array. Please hear this out properly. We still haven't taken any array. So you will be like, okay, I will take 7 and I'll increase the count to 1. So what I did was I said, I will consider this 7 to be my answer. I'm just taking a hypothetical assumption that 7 is my answer and the count is 1. And now let's start moving. We again move to 7. Like 7, now this occurs twice. 5, no, it is not 7. So you reduce the count. Remember, this count is not storing how many times 7 appears. It doesn't. It has some other significance which I'll say. Next, again 7, increase. Next, again 5, decrease. Next, 1, decrease. So whenever you find 7, you increase because 7 was your element. Whenever you find anything apart from 7, you decrease. Now you are reaching 0. Until how much? Till this portion. Let's understand what. So if you take 7, 7, 5, 7, 5, 1. This is an array. Rather, this is an array. And the count over here is 0. What does the count signify? So you took the element 7. How many times does it appear? 3 times. How many times the other elements appears? Where other includes 5 and 1. The other element appears 3 times. This is the reason when there was a 7, you did a plus plus. So there were 3 plus 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 done. And when there was 5, 5, 1, there was a minus 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 done. So 3 plus, 3 minus ended up giving you a count of 0. Can I say something for sure? If I just consider this array, 7 is definitely not my majority element. Why? If 7 was my majority element, how can you cancel? Because if an element appears more than n by 2 times, there's only one element which appears more than n by 2 times. And you cannot cancel it off. If there are 6 elements and 7 appears 4 times, can you cancel 4? To cancel 4, you need 4 more. So it's not possible. Since 7 appeared 3 times in a 6 length array, which is not greater than n by 2, it is equal to n by 2. So it got cancelled. So something that I can surely say is, till here, 7 is not my majority element. Till here, it's not. So this cannot be considered as an answer. But what I'll do is, I'll move ahead. And I'll move to 5. Okay. The moment I move to 5, I find count is 0. So what I'll do is, I will just quickly say, okay, listen, count is 0. So can you please take this as my new majority element? And probably I'll start checking from here. And my count will be 1. Perfect. So I will take 5. I'll make the count 1. Let's move 7. It's not equivalent. So I'll just make it 0. I'll just make it back 0. So this time the array finishes here and the count becomes 0. Again, eminent, if I just take this particular array, can 5 be the majority? No, that's why. Next we'll move ahead. The moment we move ahead, what will happen? Since count is 0, it will again initialize count to 1 and element to be 5. And we will start the array again from here. And this time again, let's move. It's 5, increment. It is 7, decrement. It is 7, decrement. So can I say, in this particular array, what happened? 5, 5, 7, 7. What I can say is, hey, 5 was occurring twice, 7 was occurring twice. So it got cancelled, thereby count was 0. Thereby, 5 also cannot be my answer. So till now, whoever I have considered as a majority got cancelled by similar elements. So till now, no one has dominated. We are still looking for someone who has dominated. Got it? Everyone has still now cancelled. Let's go ahead. What is the count value? Count value is 0 now. So let's move ahead. We are at a count 0. So again, we start. So count will again become 1. And this element still stays as 5. This time we'll move ahead, count becomes 2. This time we'll move ahead, count becomes 3. This time we'll move ahead, count becomes 4. And we can say we have ended the iteration. We have ended the iteration. So since we have ended the iteration, there is an element 5. This count has no significance, but we have an element 5. This element 5 will be our majority element if there exists a majority element. Why? Because everyone else got cancelled off within itself. So if there is someone still remaining who did not got cancelled, then that is my answer. But am I sure that element 5 is the majority element? What I said,
If there exists a majority element, it will be 5 and no one else. If there is a majority element, it will be 5 and no one else. If there doesn't, then okay, fine. For example, in the last portion was something like 1, 1, 1. In that case, you would have got 1 and the count would have been 4. But is 1 the majority element? If you see, 1 just appears 4 times, maybe 5. That's it. 1 appears 5 times. And when you look at the length of the array, it is 6, 2, 4, and 4, which is 8 plus 4, 12. It's a 16 length array. Someone has to appear more than 8 times to be majority. And since it was 5, let's see 5 is. So let's see how many times 5 appears. Once, twice, thrice, 4, 5, 6, 7, 8, 9. 5 appears 9 times. Out of which 4 times were not cancelled. 4 times were not cancelled. But the other times it was cancelled. So the other 5 times it was cancelled. Got it? So I can say 5 is my majority element. It's a very simple process. The first process is to apply Moore's voting algo. Okay. Now the second process, verify if the element that you got is the majority or not. How do you do it? Whatever the element is, in this case the element was 5, just iterate through the array again and see how many times 5 appears. This time it will come out to be 9, which is greater than the length 16 by 2. So that's why 5 is. If it doesn't, then it is not. Got it? So I hope you've understood the intuition. It's very simple. If someone appears more than n by 2 times, it will not get cancelled. Quite simple, right? That's the intuition. So coming back to the code editor, again the problem link will be in the description. So what do we need? We need a count 0 and we can keep an element normally. Now let's quickly start off with 0 and probably v dot size. Yes, perfect. And now can I say, first thing that I will check is what if the count is 0? If the count is 0, I know for sure this is where I'm starting a check for a new section. So count will be 1 and the element will be v of I, right? But what if the count is not 0? In that case, I will check if v of I is equal to the element that I was thinking it's the majority. If it is, please increase. If it is not, okay, let's reduce. Simple. 3 lines. If the count is 0, we just assign and we move I++. If it is equivalent, we just increase count and we move. If it is not, then we decrease and then we move. So what will happen is when you're decreasing, if the count becomes 0, when you increase and when you come back, the count will be checked with 0 and it will be replaced with the new element and it will start a new section. Quite simple. And once you've got the element, just iterate over here and v dot size and I plus plus, and you say, hey, listen, if v of I is equivalent to element, probably you can keep something like counter 1 equal to 0, and you can say counter 1 plus plus. If at the end of the day counter 1 is greater than v dot size by 2, again you can store v dot size in some variable, this particular element is the answer, or else you can say the answer is -1 or whatever they are asking you to return. So what I'll do is now I'll quickly go and run this off and see if it is running fine. No, it does according to counter 1 plus plus. Counter 1 done, and let's quickly submit this off. I hope it does run. Now remember one thing, whatever is the value of counter at the end, it doesn't represent anything. So we have to talk about the time complexity. How much? A single loop. And 3 fell, so it's a single loop. So whenever it's a single loop, you know the time complexity is very simple. It's big of n for the first iteration of the Moore's voting algo. And if they are stating that the array might have or might not have a majority element, then you go and verify. This step will not be done if the problem states that there always exists a majority element. Then this step will never be done. Okay, you only do this step if the array might not have a majority element. Got it? So this will be the time complexity, and we are not using any extra space, so this will be the space complexity. It states that you'll be given an array and that will be consisting of integers, and you have to return me all the integers that are appearing more than floor of n by 3 times. What does it mean? So over here n is given as 8. So if I write 8 by 3, the value will be 2 point something. So if I take the floor of the division, it will actually be 2. So you have to return me all the integers that are appearing more than 2 times. So can I say 1 is definitely one of the integers that is appearing more than 2 times because it appears 3 times? And can I definitely say 2 is another integer that is appearing more than 2 times because 2 is also appearing 3 times? So there are 2 integers that are appearing more than 2 times, and these 2 integers have to be returned. So before we move on to the solution, I have a very simple question for you. How many integers do you think at max will be there in the answer? Like over here, you did see that the answer had 1 and 2. So there were at max of 2 integers. So I ask you, how many at max will be there in the answer? Can I say the answer will be at max having 2 integers? Can I say this? Why? So over here n was 8, and when I did a floor of it, the value that I got was 2, correct? And I wanted someone greater than 2, like any element that is appearing more than 2 times. So more than 2 times means at minimal it will be 3. At minimal it has to appear 3 times. So if I take 3 plus 3, it's giving me 6. But if I take 3 integers, each of them appearing 3 times, then the total will be 9 integers. And but n was just 8. So can I definitely say that at max there will just be 2 elements which will always appear greater than floor of n by 3. I can take any other value of n. Imagine you take n as 9, and if I do something like 9 by 3 and a floor, that gives me 3. If I take more than 3, I want integers that are appearing more than 3. So that is at a minimum of 4 times. 4 plus 4 will be 8. And if you add another one which appears 4 times, it becomes 12. But n was just 9. So at maximum, the answer just can have 2 integers. At minimum, it can have 0 integers. It can have no one appearing more than n by 3 times. But at max, we can just have 2 integers. So that is the first thing we have observed. So we know something for sure, that the answer will always have 2 elements. Now, what is the first solution that comes to your mind? Like the brute force. The brute force is very simple. What you say is you pick up every element and you check through the array which is appearing more than floor of n by 3 times. And that is the extreme brute force. So probably I'll take a list which is initially empty. I just take it. Then I move forward and I again see 1, but that is already in the list. If it is already in the list, I'll not do anything. I'll just move. And then I have a 1 and I again see it is already in my answer. So I'll not do anything and I'll move. I say I have a 3. If I say I have a 3, I pick up 3 and I'll probably start counting it. And it's like, no, 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 yes, yes, no, no, no. So 2 times, which is not greater than floor of n by 3. So nothing to be done. Let's move ahead. We have a 3. Again the same thing. Next we have a 2. The moment you take a 2, no over here, and then a yes. So 3 times, which is more than floor of n by 3 times. Thereby 2 will be in the answer. The moment you see that the list has 2 elements, you can stop. You can stop the iteration over here because you know at max you'll just have 2 integers that can appear more than floor of n by 3 times. So you just stop and you can return this list as the answer. So let's quickly write down the pseudocode for the brute force. So can I say I'll probably take a list which is initially empty, and then I'll start iterating from I equal to 0 till the last index, which is n minus 1. And I know one thing for sure. If the list is empty, then I need to check. I don't need to do anything. I can just go ahead and take that element and count in the entire array. Or I can say, if the list is not empty, then whatever is at the first index, whatever is at the first position, I will say if that's not equal to the current element, can I say this? That means this is not a part of my answer. So what I'll do is I'll probably keep a count equal to 0. Is count equal to 0? And then I'll just run a loop from j equal to 0 to n minus 1. And I'll say, hey, listen, if array of j is equal to this particular nums, or rather nums of j, if nums of j is equal to nums of I, then cool, please keep a counter plus plus. So once this entire for loop is over, I can simply say if counter is greater than n by 3, then what I say is list, can you just add this possible element, and you will add it. And this is how you do it. So basically what I did was, if list has no answer, we check for the element, or if it has one element, then I'll say if that one element is not equal to the current, then go and check. And it just simply does a linear search. And once this if is completed, what you do is, if at any moment the list size becomes equal to 2, you break. There's no need to do any further. I'll do hash it. And that is when I'll probably take I'll take up the first element, which is 1. Worst time complexity is big O of n. Okay, so this is how easily you can do the better solution. But obviously the interviewer will not be